So this is the chapter 3 test review. So we're going to go through these questions. So to complete this 2-column proof, we are going to use our little picture that we have. We're going to use each option once. So I'm given my picture x, y, y to z. I know x, y is 4x, y, z is 2 multiplied by x minus 3. And I know x, z, this entire length from here to here, is actually 30 because they give me that. So the first step they have filled out for us, this is using segment addition postulate. So they're just writing out the picture x to y plus y to z equals x to z. Going from this step to this step, they are plugging in the information. I know xy is 4x, yz is this, xz total length is 30. So from this step A to step B, we're using substitution property of equality. Substitution property of equality is replacing variables with what they are equal to. Going from B to C, from here to here, we have to look what we're doing. They have parentheses and then they're getting rid of the parentheses. So I'm actually using the distributive property to get rid of my parentheses. 2 times x makes 2x. 2 times 3 makes 6. So this is the distributive property. The next step from C to D, 30 is still the same, minus 6 is the same. The only thing they did is combine like terms. They combined 4x and 2x to make 6x. So we're going to say combine like terms. From this step to this step, if you notice my 30 now changed to 36, my minus 6 is gone because what they really did is add 6 to both sides. 30 plus 6 is 36. So this is technically addition property of equality. And I'm going to shorthand this. So combine like terms, addition property of equality. The last step, going from E to F, I have to get rid of the 6 in front of the x. So I divide by 6 on both sides. This is division property of equality. Number 2 is conditional statements and using the converse, the inverse, contrapositive, and biconditional to rearrange the sentence. So it says if 2 points are collinear, then they are on the same line, which is a true statement. So collinear points fall on the same line. We have to identify the following statements if they're contrapositive, converse, or inverse based on the original sentence. So you're always going to reference back to the original. So now my sentence is if 2 points are not on the same line, not and not, then they are not collinear. Notice the word collinear was in the front, now it's in the back. Same line was in the back, now it's in the front. So they switched the sentence. Normally it's P to Q. They switched it, Q to P. And they also negated the sentence. So they made it negative, meaning opposite of what it was. If it was negative, now it's positive. The original was positive, so I'm making it negative. So I switched them and I made it negative. So negating it and switching it is a contrapositive. Using the original sentence, if 2 points are collinear, then they are on the same line. That's my original P to Q. Now I have if 2 points are on the same line, they are collinear. These are not negative. They're not negated at all. All they did was they took collinear, which was in the front, now it's in the back. Same line was in the back, now it's in the front. So they just switched Q and P. So that is a converse. The last sentence says if 2 points are not collinear, then they are not on the same line. So the sentence is exactly the same as original. They just added the word not. They negated it. They made it negative. So it's negative P to negative Q. They didn't switch the sentence or flop the sentence. So this is your inverse. Your inverse and your contrapositive are your negatives or opposite of whatever it's saying. Number 3 says, if possible, write the definition as a biconditional statement. A biconditional has to use specific words. Those specific words are if and only if. So you're looking for these words specifically. So when two lines are perpendicular, remember your symbol for perpendicular is technically an upside down capital T, then they form a 90-degree angle. So I'm looking for a sentence that says if and only if, because this is my P to Q. Biconditional is P, if and only if, Q. So they're not rewriting the sentence at all. They're just adding in that middle section. So if you look at your different options, that's going to be C because it says if and only if. Number 4 is the second proof that's on the test. It is proving that lines are parallel. So I'm given that angle 1 and angle 2 are congruent. I have to prove line L is parallel. These double lines mean parallel to M. So I have 3, 2, and 1. It says angle 1 is congruent to angle 2. That is given. I know 2 is congruent to 3. If I look at where these are at on my picture, angle 2 is here and angle 3 is here. Those are alternate interior angles. They're interior because they're on the inside of the parallel lines. Think about a sandwich on the inside. They're on opposite sides of the transversal. So they are going to be alternate interior. The next one says 1 and 3 are congruent. If I look at 1 and 3, 1 is here, 2 is here. Those are congruent to each other. They're actually corresponding angles. Corresponding angles is not one of my definitions that I have. So if I look at the information I'm given, I know 1 is congruent to 2, 2 is congruent to 3, and then they jump to 1 is congruent to 3 because they're justifying if I know 1 is congruent to 2 and I know 2 is congruent to 3, I can take out that middleman and just say that angle 1 is congruent to angle 3 using the transitive property. Going on to number 5. Number 5 is technically a review of old stuff. It's parallel lines cut by a transversal, and it's solving an equation. So you have Peach Street, Cherry Street. Your transversal is Apple Street. It says Peach Street and Cherry Street are parallel. Apple Street intersects both of them because that's the transversal, as shown in the diagram. If the measure of angle 1 is 2x plus 12, and measure of 2 equals 6x, what is the measure of angle 2? This is where I say, if they're giving you a picture and you have a math problem, plug in your information. Using the pictures there to help you. So I'm going to put measure 1. I'm going to put 2x plus 12 where measure 1 is technically. And I'm going to put 6x where measure 2 is. 6x is here. So I have to decide, do they add to make 180 or are they congruent to each other? If I look at these angles, angle 1 is a very, very teeny tiny angle. It's just a little baby angle. It's acute. It's small. Angle 2 is significantly wider than angle 1. So the width of it, this is an obtuse angle. This is an acute angle. They are not congruent to each other. I cannot put an equal sign between them. They are supplementary. So I can do 2x plus 12 plus 6x equals 180. Because realistically, I could, if I wanted to, I could slide 6x right here because of corresponding angles. That's making them a linear pair. They add in total to make 180 degrees. So since they're different angles, parallel lines cut by transversal, they're different. I'm going to add them to make 180. So I'm going to combine, the light's turning off. I'm going to combine like terms, 2x and 6x together, make 8x plus 12 equals 180. And now I'm going to move my constant over across my equal sign. So I'm going to minus 12, minus 12. So I have 8x equals 168. And then I'm going to divide by 8 to both sides. So if I take 168 and I divide by 8, I get x equals 21. And now I'm going to take that information because that's not the answer. It doesn't say x equals. It says measure of angle 2 equals. So I need to figure out what this obtuse angle is actually equal to. It's not equal to 21. 21 would be an acute angle. So I'm going to do 6 multiplied by 21. So I'm plugging it in. 6x is really 6 times 21 because now I know x is 21. So I'm substituting it back in. 6 times 21 is 126. So 126 degrees is measure 2, which makes sense because it's an obtuse angle. It's large and in charge. Okay. Moving on to number 6 on the back side. So on the back, we still have parallel lines cut by transversal. Once again, we have to decide, are they congruent or are they supplementary? Do they add to make 180 or do we set them equal to each other? So if I look at what's given, I have this exterior angle and this exterior angle. This is an acute angle. This is also an acute angle. They are congruent to each other. I know this because they're technically alternate opposite sides of the transversal. They're alternate and they're exterior. They're on the outside of that sandwich. So they're on the top of the bun. They're outside the sandwich. So these are alternate exterior angles, and I'm going to set them equal because they're both acute angles. And now you get to pick what you want to move. I'm going to move the -4 because it says minus, so I'm going to add it. Numbers have to go with numbers, so I'm going to add it to the 8. So 7x plus 12 equals 9x. Because I moved my 4 from the right to the left, I'm going to move my x from the left to the right. So I'm going to minus 7x, minus 7x. So 12 equals 9 minus 7 is 2x. Divide by 2, divide by 2, x equals 6. For number 7, this one gives you a lot of extra stuff that you don't technically need to look at. It says LMN. So this angle right here, LMN is 40. I want to use a highlighter. It's my pen. LMN is 40 degrees. I also know that LMN is congruent to OMP. OMP. So this is also 40 degrees because if one side's 40, the other side is 40. We need to find NMP. So you have a bunch of extra lines here. NMP is this interior angle right here. So what we're trying to find. So you need to kind of disregard the extra information. These 3 angles together add to make a straight line. A straight line is 180 degrees. So what I'm really doing is I have to think about 40 plus something plus 40 needs to make 180. So you could write out an equation if you want, or you can use process of elimination, like use your brain power. These 3 angles need to add to make 180. I can combine 40 and 40 to make 80. Something plus 80 needs to make 180. Minus 80 to both sides if you need to. And if you don't, like, if you can do this without showing work, I'm fine with that. You get 100 degrees. So the measure of NMP, this angle, the missing angle, is 100 degrees. The next one is has a piece of information that you need to know what the symbol means. It says EF upside down capital T. This is that piece of information that you need to know. This means perpendicular. Perpendicular means 90 degrees. So EF is perpendicular to FH. So they're saying that together, these angles make a square. Together, these angles make 90 degrees in total. And I know the measure of EFG is x plus 16. And GFH is 3x plus 2. We have to find the measure of EFG. So I'm doing angle addition postulate. I'm taking the smaller angle, adding it to the other smaller angle, equaling it to the outside, which is 90. So I'm doing x plus 16 plus 3x plus 2 equals 90 degrees. Combine like terms, 1x and 3x make 4x. 16 and 2 make 18. I'm going to minus 18 to both sides. And then divide by 4. So x equals 18. It wants the measure of angle EFG. EFG is x plus 16. So I'm really doing 18 plus 16. I'm substituting it back in. So the measure of angle EFG is technically equal to 34 degrees. This next one is extra credit. It's determining the perimeter around a triangle, rounding to the nearest hundredth if needed. So we have to find the length of each segment. So I'll do A to B first. So A's point is 5, 5, B is 1, 7, and I'm using the distance formula. So the distance formula, I'll write it up top for you. The distance formula is x2 minus x1 squared plus y2 minus y1 squared. So in parentheses, I'm going to have 1 minus 5 squared plus 7 minus 5 squared. So if I simplify, 1 minus 5 is -4. 7 minus 5 is 2. If I square them, -4 squared is positive 16. 2 squared is 4. I'm taking the square root of 20. And I'm rounding to the nearest hundredth. So if I take my calculator, you're taking 20, shift square root. So you get around 4.47. So this length is 4.47. I have to find the other two sides now. So I'm going to use A, which is 5, 5, and C, which is 3, 2. So I'm going to do the same thing over again. So I have 3 minus 5 squared plus 2 minus 5 squared. X's subtract, Y's subtract. 3 minus 5 is -2. -2 to the power of 2 is 4. 2 minus 5 is -3. -3 to the power of 2 is 9. 4 plus 9 is 13. If I shift square root, I get around 3.61. So this length is 3.61. So now I'm going to do the last side, which is from B to C. So B is 1, 7. B is 3, 2. Once again, I'm using that same formula from the top. I'm going to take x2 minus x1, y2 minus y1. So 3 minus 1 squared, 2 minus 7 squared. 3 minus 1 is 2. 2 squared is 4. 2 minus 7 is -5. -5 to the power of 2 is 25. If I add them together, I get 29. I'm going to shift square root. I'm sorry, I'm kind of combining steps because I'm running out of space. 5.385, so I'll say 5.39. Since it wants the perimeter, I'm going to add up all my sides. 5.39 plus 4.47 plus 3.61. So the perimeter is around 11.47. Did I do that right? 4.47 plus 3.67 plus 5.39 plus 3.61 plus 4.47. Oh, no, I didn't. Okay, that looked wrong. Oh, wait, let me re-add these. 4.47 plus 3.61 plus 5.39. Okay, that was wrong. I had something in my calculator when I first started. So the perimeter is not that. It's 13.47-ish. Okay. So that's the answer. Last one. It says in the figure I have this, they're opposite rays. The important part is that CA ray CA is bisecting BCE. So these angles are congruent. Bisecting means it's cutting it in half. So you kind of are disregarding this portion of the line. You can cut off that piece. You're just looking at these. Geometry, they like to give you a lot of extra pieces of pictures. So disregard what you're not using. I know that CA bisects BCE. That's the important part. So it's cutting it equal parts, equal half. So it says ECA is 5x minus 17. Once again, you should be using the picture to help you, plugging in your pictures information. ACB is 2x plus 28. What is the measure of ECA? So disregarding this piece, I know these are congruent because it's bisecting it. It's cutting it in half. So I'm going to do 2x plus 28 equals 5x minus 17. You get to pick what you want to move. I'm going to move the 17 because it's negative. So I'm going to add 17 to both sides. So I get 2x plus 45 equals 5x. Now I'm going to minus 2x to both sides. So I have 45 equals 3x divided by 3. X equals 15. Now I'm going to take my x and I have to plug it back in. ECA is technically 5x minus 17. I'm substituting in my x value. So I have 5 multiplied by 15 minus 17. 5 times 15 is 75. Minus 17 is 58 degrees.